Hello, welcome everyone. Today we are going to discuss mostly theoretical concepts, but which are very important to write any C program. Please try to concentrate on the topics which we are going to discuss today. In C, delimiters are used for syntactic purpose, and we have 7 delimiters in C. They are as mentioned in this table. This was the program that we have seen in previous video. So in this delimiters, colon is used for label in switch case, and here square braces are used to declare arrays. So these two we are going to discuss in upcoming videos. Second one, semicolon. As we know, every statement in C will end with an semicolon, and this we have already seen in previous program. See, every statement have semicolon, and parentheses are used for expressions. So these parentheses were used in this program already after function. In main function we have seen, and printf function we have seen, and curly braces. So curly braces mainly used for block of statements. See here, this printf statement and return, these two are one set of statements, and these curly braces are used for these two block of statements. Similarly, when you have group of statement, we will use curly braces. And hash is used as a preprocessor directive, and here you can see while including header files we have used hash. Other than header file inclusion, hash has some other uses that we will discuss in other video. Comma we will use when we are declaring more than one variable of same data type, and this we will discuss later in this video only. Next we are going to discuss about keywords. There are certain words that are reserved for doing a specific job in C programming. These words are called as keywords. In C we have 32 keywords, and these keywords always will be in lowercase. So these are the 32 keywords which are in C programming, and the keywords which are highlighted in yellow color, those we are going to discuss today. See, all keywords in lowercase only, and we cannot use these keywords for other jobs as these have some predefined tasks. Next, conversion specifications for printf. In last program we have seen how to print a statement on the output screen using printf statement. So whatever written in the double quotes, that will be printed on the output screen as it is. But we have some conversion specifications to print a integer, float, character, like that. So now we are going to see those conversion specifications. Mainly these conversion specifications are used to specify the type and size of the data that we are going to print on the output screen. Each conversion specification will start with percentage symbol. Percentage %C is used to print a single character. Percentage %D and percentage %I are used to print a decimal integer. Percentage %U is used to print an unsigned decimal integer. Percentage %O is used to print unsigned octal integer. In hexa number system, we have 0 to 9 digits and A to F alphabet. So A to F will be printed in lower case when we use percentage %X. If we want to print A to F in uppercase, then we need to use percentage $X. Percentage %F is used to print a floating point number. When we use percentage %F, then 6 digits after the point will be displayed on the output screen. Now let us see few simple programs and these conversion specifications. See, this was the simple printf that we have used in previous program. So in this there were no conversion specifications. Only there was a simple statement hello world, and this will be printed on output screen. Now let us first see how to use percentage %C to print a character. The conversion specification every time will start with percentage, and now we want to print a character, so I am using C. Okay, and these conversion specifications will present within the double quotes. We need to give comma here, and whatever the character we want to print on the screen in place of this conversion specification, that we need to give after comma. As it is a character, we should give the character within single quote. For example, S. So this is how we use conversion specification. The conversion specification will be within double quotes followed by a comma, and then we'll give the data whatever we want to print instead of these conversion specifications. So this S will be printed in this place, in %C place. Let us build and run. See here, on output screen, alphabet S is printed. For example, if I want to print 2 characters on the output screen using conversion specifications, then I need to give %C 2 times within double quotes, comma, and one character and another character like R. So in place of first %C, S will be printed, and in place of second %C, R will be printed, and these will be separated by a comma. It is a delimiter. Now let us build and run. See, the 2 alphabets S and R are printed on the output screen. Now let us see how to use %D. %D is used to print a decimal integer. The syntax is similar to the previous one. The %D will be within double quotes and comma. So previously it was a character, so we kept the character within the single quotes. Now we are going to print a decimal integer, so simply we can give some decimal integer 10. Okay, now on the output screen, instead of %D, 10 will be printed. See here, in the output 10 decimal integer is printed. And similarly, if you want to print one decimal integer, one character, that we can do %D and some %C. I want to print 10 as a decimal integer and some character A. So build and run. See here, in place of first conversion specification %D, 10 is printed. In place of second conversion specification %C, alphabet A is printed. And for example, if I use comma here, \n at the end, see how the output will be. See here, the basic use of printf is whatever within double quotes, that will be printed, except these conversion specifications and escape sequences such as \n. So first, after double quotes, we have %D, which is a conversion specification. So in place of this, 10 will be printed, and then we have a comma. So comma will be printed as it is, and then we have conversion specification %C. So in this place, A will be printed. As we have used \n, one new line is printed. %I also will work same as %D. So in place of %I, 10 is printed. %D and %I are used to print both unsigned and signed integers. For example, if I want to print some -10, then I should use either %D or %I. See, along with that integer, the sign also is printed, minus. If you want to print an unsigned integer, then you can use %U also. As it is unsigned, it should be positive. See, in place of %U conversion specification, 10 is printed. If you want to print a floating point number, then we need to use %F. See, now I want to print some 10.10. Build and run. See, as we discussed, after point there are 6 digits. Hope you all know the different numbering systems like octal number, binary numbers and hexa numbers. So at this point of time, if you don't know, also it is fine. Let us use a calculator to do number conversions as of now. In calculator, select programmer mode. Then you will see all the number systems here. For example, for a decimal 10, A is the equivalent hexa number, 12 is the equivalent octal number. So to print a octal number on the output screen, then we need to use %O. I would like to print 10 decimal. But as I used conversion specification %O, 12 should be printed. So 12 is the equivalent octal number for 10 decimal. And in hex, A is the equivalent number for 10. Now if I want to print hexa value, then I need to use either small x or capital X. I am using small x first. Build. As we have used alphabet X in lower case, A is printed in lower case. If I use capital X here, then capital A will be printed. Now let us see all the conversion specifications that we have discussed as of now in one single program. This is the output. %C is used to print a single character S. %D is used to print a signed integer -10. We also can use %I instead of %D. We can use %D to print a positive integer also, like 10. We also can use %U to print a unsigned, that means in positive number on the output screen. %F is used to print a floating point number. and this percentage F can print up to 6 digits after point. Percentage O is used to print octal number. 12 is equivalent octal number of decimal 10. Percentage small x is used to print hex in lowercase. Percentage capital X is used to print hex number in uppercase. Now let us see few more conversion specifications. Percentage small e, which is used to print a floating point number in exponential format like 10 to the power of 3. Percentage capital E is used to print that exponential in capital E. Percentage G is used to print a floating point number either in percentage F format or in percentage E format, which have the shorter length. Percentage G, capital G, works same as percentage G only, but that exponential will be printed in uppercase. Percentage S is used to print a string more than one character. Percentage is used to print percentage sign. See, for example, if I want to print a floating point number like 1000.10, then here I am using percentage F and output will be 1000.1 and 5 zeros. Percentage E is also used to print a floating point number but in exponential format. See how this is printed. In exponential format it is printed like power 3. If we use percentage capital E, that exponential symbol will be printed in uppercase, and percentage G is used to print a floating point number either in percentage F or percentage E format only, but whichever is shorter in length. For example, if it is 1000.10 and if I use percentage G, then it will be printed in percentage F format because that exponential format will be longer than this. For example, if I have a big number like this and I use percentage G, then see it will be printed in exponential format because it is shorter in length. The length is nothing but the number of characters printed here in the output screen. Same capital G is used to print that exponential symbol in uppercase. See here, E is printed in uppercase. See, percentage S is used to print a string, nothing but group of characters. In C, single quotations are used to represent a single character and double quotations are used to represent a string. In place of conversion specification percentage S, string will be printed. See here. Let us see how to print percentage symbol on output screen. To print percentage symbol, we need to use percentage symbol twice. Let us build this program. See, on the output screen, percentage is printed. We have percentage P, which is used to print pointer in hexadecimal format on the output screen. We shall discuss about percentage P when we discuss about pointers. Next, identifiers. All the words that we use in our C program will be either keywords or identifiers. In the beginning of this video, we have seen what are the keywords. Those are reserved words, and identifiers are user defined words. And these identifiers basically used to give names to entities like variables, arrays, functions, structures, unions, etc. Now let us see what are the rules for naming an identifier. First rule is identifier should consist only alphabets in lowercase a to z and uppercase a to z, digits from 0 to 9 and special character underscore. And first character should always be an alphabet or an underscore. And we should not use keywords as identifiers. C is a case sensitive language, so uppercase and lowercase are considered different. For example, count, capital C and remaining are in lowercase, and all are in uppercase and all are in lowercase. But these three will be considered as three different identifiers in C programming. So these are the simple rules to name an identifier. Now let us guess the identifier which is displayed on screen is valid or not. So value, it is valid because it has all alphabets only. And 5S, is it valid? No, because identifier should start with an alphabet or with an underscore. Underscore data, yes, it is valid because it has underscore as a first character and remaining are alphabets only. A hash, it is not valid because it has special character hash. First space value, it is invalid because space is not allowed in naming an identifier. Now let us see a few fundamentals of memory management. Basically we have two types of memory. One is program memory, which is nothing but ROM, read-only memory, and it is a permanent memory. Our program file, whatever the code file that we are writing like main.c and executable files will be stored in program memory. And second one is data memory, which is nothing but RAM, random access memory. It is a temporary memory. While executing our code, the code instructions will be temporarily loaded to RAM, and it also stores intermediate results. For example, if we are performing some arithmetic operations, that temporary result will be stored in RAM, and also it stores the variables during our program execution. While writing a code, we see signed decimal values, unsigned decimal values, floating values, characters, strings, but at the low level, at the mission level, everything will be in zeros and ones. That 0 or 1 is called 1 bit. 1 nibble contains 4 bits. 1 byte contains 8 bits. So for example, if this is a memory of 1 byte and these are the bit numbers like bit 0 to bit 7. This is lower nibble and this is upper nibble or higher nibble. Now let us see few examples how the data will be stored in a byte. For example, if I want to store a value 14, a decimal value 14, the binary value of 14 is 1110. As of now, we can use calculator to convert decimal value to any other numbering system, to binary or octal. But I am sure by experience you will be able to do this without calculator. Now let us see how this 14 value will be stored here in this byte. See here 0 1 1 1. From lower nibble it is stored 0 1 1 1. By default the remaining bits will have zeros. This is called ASCII table. So whatever the keys we have on keyboard, every key have equivalent decimal value, so that key value will be stored in form of zeros and ones, and this ASCII table you can easily download it from Google. See, for example, when we store a alphabet A in memory, so the equivalent binary value of A is this 0 1 and zeros and last bit is 1. This is how A will be stored in a byte of memory. See, in lower bit it is 1 zeros, and in the sixth bit 0 it is 1, bit 7 it is 0. For example, if I want to store character 1, so character 1 is here and equivalent decimal value of character 1 is 49, and this is a equivalent binary number. So bit 0 to bit 7. See, this is how character 1 will be stored in a byte of memory. I do not want to confuse you by explaining memory concept in depth at this point of time, but sure we shall discuss on memory management clearly in a separate video. Now let us see what are the data types available in C. Data types are basically used to tell compiler that what type of data we want to store in memory. There are 4 fundamental data types in C. They are int to store a integer value, char to store a single character, float to store a floating point number, and double to store a floating point number with a higher precision than float. We can use some type qualifiers with these basic types to get more types. Qualifiers available in C are size qualifiers, those are short and long. Sign qualifiers are signed and unsigned. These 4, short, long, signed, unsigned, are the keywords. So finally let us see what are the data types available in C after using type qualifiers with the basic types. So basic data type is char and data type with the type qualifier signed. So by default char is nothing but signed char only. Basically size of int depends on the machine. It differs from 16-bit machines to 32 or 64-bit machines. So that is why I added one extra column here. So for char, let us see what is the size in 16-bit machines. It is 1 byte. 1 byte and range will be from -128 to 127. And no need to by heart these ranges. I will show you how to know what is the range of the values based on size of bytes. So 1 byte is nothing but 8 bits. So 2 to the power of 8. It is 256. The maximum value is 256. But as it is signed data type, the range will have for both signed and unsigned. So just do divided by 2. So 128. The range will be -128 to 127 because we have 0. That is why the maximum range will be -1. It is 127 instead of 128. So for 1 byte data, if it is a signed type, the range will be -128 to 127. And in 32 and 64-bit machines also, character size will be 1 byte. Basic data type is char only and data type with type qualifier as unsigned. Size will be 1 byte and range will be 0 to 255. So in unsigned we don't have negative numbers. So that is why the whole range will be for positive values. So it is 0 to 255. Same in 32 and 64-bit machines. As character is 1 byte size, we can only use signed qualifiers, both signed and unsigned. Size qualifiers we cannot use because we cannot have a data which is less than 1 byte. And next basic type is int and qualifier we are using it is a sign. So by default int also considered as signed. Size of int in 16-bit machines is 2 bytes. Now let us do the calculation. For 2 bytes size. 2 bytes means 16 bits. 2 to the power of 16. It is 65,536. And as it is signed, so for unsigned it will be 0 to 65,535 -1. So and for signed it will be divided by 2. So it is -32,768 to 32,767. And in 32 and 64-bit machines, int size is 4 bytes. Similarly, let us calculate the range for 4 bytes. 2 to the power of 4 bytes means 4 into 8, 32 bits. So for unsigned, it will be -1 to this value. And for signed, divided by 2. See the range. Only for the positive, we need to do -1. As we have 0. And when we use unsigned qualifier, size remains same, it is 2 bytes, but range will be double. In 16-bit it is 2 bytes and in 32 it will be 4 bytes. And next we can use size qualifiers for int basic data type. So here I am using when we use short size qualifier, by default any data type will be signed. So short int and signed short int both are same. 16 bits it will be 1 byte. You know how to calculate the range. And in 32 bits and 64-bit machines it is 2 bytes. And then unsigned short int. Same size remains same. In 16-bit it is 1 and in 32 and 64-bit it will be 2 bytes. And long int, signed long int both are same. And size of long int in 16-bit machines is 4 bytes. And in 32 and 64-bit machines also it is same, 4 bytes. And then unsigned long int. Size will be same as long int but range will be double. And then basic type float. Size of float is 4 bytes and this is a range in exponential format. Same in 32 and 64-bit machines. We cannot have a floating value less than 4 bytes, and we cannot have unsigned also. So that is why we cannot apply any qualifiers for float. And size of double is 8 bytes in both the missions, and range is as mentioned here. Let us clearly discuss how floating value is stored in memory in next video. As of now, understand how a character and how an integer number will be stored in memory. I mean the bit format from lower bit to higher bit. Now let us discuss about variables. Variable is a name that can be used to store values. That means we are giving some name to a memory location, and variable can have different values but one at a time. For example, one time it may have some value. After executing few instructions, we can vary the value. And let us see how to declare a variable. So while giving name to a variable, we must follow the rules which we have seen for naming an identifier. The same rules applies here, because variable is also an identifier, and we must declare a variable before it is used in the program. Declaration is nothing but telling compiler that we want some space to store data, and the type and range of that data depends on the data type. Syntax for declaring a variable is first the data type, like int, signed int, char, unsigned char, like that, and followed by variable name and semicolon as end of statement. Example is, if I want to declare a variable to store integer value, so then the data type should be int and variable name. Here I have given value as a variable name. We also can give like a, I, j, something. Always make sure the variable name you are giving has some meaning, because in a project when you are working in a real time, you will have thousands of variables. If you give simply a, I, something, it will be difficult to understand what is the purpose of that variable and what you want to do. So always prefer to give some meaningful names to any identifier. And here in this statement, alphabet, it is a variable, nothing but we have given a name alphabet to a memory location, and in that memory location I can store a character. Nothing but 1 byte of data I can store in that memory. Now let us see few example programs on data types and variables. We discussed that size of int depends on mission. So it differs from 16-bit to 32 or 64-bit missions. In C, we have a keyword sizeof, which is used to get size of a data type or size of a variable. Now let us see how to use sizeof keyword to get size of a data type. I am using Printf to print size of a data type on output screen. So as size will be always unsigned, I am using conversion specification u, comma, here size of keyword, and within parenthesis we can give the data type, for example some int. This printf statement prints size of integer and current mission. Let us build and run the program. So in this mission, size of int is 4 bytes. Similarly, we can get to know size of any data type. For example, short int. So size of short int is 2 bytes and size of double, so it is 8 bytes. Like this, we can get to know size of any data type. Now let us see how to declare a variable. Declare an integer variable, and variable name I am giving var. So what is the meaning of this statement is, var is a variable of integer type. That means to a memory location we have given a name var, and in that memory location we can store an integer value of 4 byte size data. Now let us use printf to print the value of variable. As the variable is integer type, I am using %d conversion specification, comma, variable name. Let us build and run the program. See here, value of variable var is 0. But if you observe, we never assigned a value to this variable. Simply we declared the variable and we printed the value of variable, and it shows 0. That means by default the value of variable is 0 in this compiler. In fact, the value of a uninitialized variable depends on the compiler. So in this compiler, the value of uninitialized variable is 0. but in some compilers it may be a garbage value. So it is always recommended to initialize a variable at declaration time to avoid using garbage values. We can vary the value of a variable multiple times, but at a time it can hold only one value. So now see this program. So in first statement, one variable is declared and it is initialized with 0. We have a printf to print the value stored in variable var, and then we updated var value to some 10, and then we have another printf to print variable var value. Let us build and run the program. So here, before updating var value to 10, var value is 0, which is the initial value. But after that, when we try to print var value, it is 10. That means 0 is overwritten by 10. So after this statement onwards, value of var is 10. So like this, we can vary value of any variable multiple times, but at a time it can hold only one value. Similarly, we can simply change the data type as per our requirement and declare any variable and use that variable in our program. Accordingly, we need to change these conversion specifications in the printf statement. Let us see how to declare a character variable. For example, some char letter. So here letter is a variable name of character type. That means here in this letter variable we can store one single character, and I am assigning some a to this variable. Using printf, we can print the value which is stored in the variable letter. Since it is a character type, we need to use conversion specification %c, comma, variable name letter. So build and run. See here, in place of this conversion specification, whatever the value stored in variable letter is printed on the screen. Actually, we can combine these two statements like this. Some character letter equal to an alphabet A. Both are same. So we are declaring a character variable and initializing that variable value to alphabet A. So similarly, we can write programs for other data types, and we can use sizeof operator to print size of this variable also. Previously, we have seen how to print the size of a data type. Similarly, sizeof operator we can use to print size of variable. Simply within parenthesis give that variable name, and as it is a size, I am using %u. Run the program. See here, size of this variable letter is 1 byte. So this is how we can use the sizeof operator to print size of a variable or size of a data type. And when we want to declare two variables of same data type, we can use delimiter comma. Example is, I have some letter 1 and some letter 2. Letter 1 is initialized with an alphabet A. Letter 2 is initialized with an alphabet B. As these two are of same data type, instead of having two statements, we can combine these two statements into a single statement by using delimiter comma. After assigning value to letter 1, we can use comma and letter 2 equal to B. That means we have two variables of character type, and using printf, let us print value of these two variables. So first character value is A and second character value is B. So like this, we can also declare integer or float, any data type. Like this, we can use delimiter to declare multiple variables of same data type. And one more basic rule to use a variable is we must declare the variable before using it. For example, here see, first we declare the variables and then we have used those variables in printf statement. So instead of that, if we don't declare the variable, then see how compiler reacts. It shows compilation error. It is that variable letter 1 and letter 2 are undeclared. So we must declare a variable. That means we need to tell the compiler that we are going to use these two variables in our program. So finally, today we discussed discussed about delimiters and we got to know how many keywords available in C, and in these 32 keywords we have seen the purpose of the keywords which are highlighted in green color, and remaining keywords we can discuss in upcoming videos. And we discussed about conversion specifications for printf like %d, %i, %c, etc. And we have seen what is an identifier and what are the rules for naming an identifier. And we have seen fundamental concept of memory management like what is RAM and what is ROM and where our code is stored, how data is stored in a byte of memory, etc. We have seen what are the data types available in C, and we have also seen what is a variable and how to declare variable, and we also have seen simple programs on these topics.